Okay, so what you need to do the work lab is you need a rod clamp, you need a ramp clamp, you need a couple of masses, a friction block, you need a support rod, and a ramp. So first you're going to attach the support rod clamp and the support rod. Then you'll put the ramp clamp on. And the way that you can see that this nut right here is going to go through the groove of the ramp, like so. So that slides in and out like that. Okay? So once you have everything connected, what you're going to do is you're going to start with a distance that you will not change, a vertical distance which will not change. Okay? So the ramp clamp is going to be attached to the pole, and at this point you want to keep it there. So you want to measure this distance and make sure that never changes. Next is you're going to also measure what is the length of the ramp. And that's going to be from the beginning here all the way up the ramp till you reach the ramp clamp, or we'll call that the highest point. This is going to be the vertical height that we're trying to reach. Next you're going to put your friction block with the two masses inside, and you're going to attach the force sensor. So after you zero it out by hitting the zero button with no tension in the string, zero it out and make sure that you pull it perfectly parallel to the surface of the ramp. This is not parallel to the ramp. This is not parallel to the ramp. Make sure you're pulling it parallel to the ramp. Next, it doesn't matter how far up the ramp you actually pull it. What's important is that we measure what is that overall distance. In other words, by measuring the distance, we're trying to imply that the angle is different. In other words, we're going to change the angle of this for every trial. So you're going to pull that, get your data point, then you're going to loosen this, okay? And you're going to move the track up. Notice how I'm moving the track back 10 centimeters. I want you to measure that with a ruler. I'm not doing that here, but you're going to measure a 10 centimeter difference. And then you're going to measure your new ramp length. Your new ramp length from the bottom all the way to this highest point right here. Okay, we don't care about the extra that's hanging off. We just want to go from here all the way up to this original height that we chose. Then we're going to do this again. We're going to zero it out. Make sure that's zeroed out with no tension in the string. And then we're going to pull it perfectly parallel just for a couple seconds until we get a good reading. Again, you're going to loosen this nut. We're not going to change the height. Notice we're not changing the height. And we're going to pull this ramp back another 10 centimeters. I want you to measure that. I'm not doing that here. Tighten that back down. And notice that it keeps getting shorter and shorter. Okay? That means the overall distance of our ramp to the maximum height is changing, and we have a little extra at the end that we're not concerned about. You're going to zero this out again with no tension, and you're going to pull it parallel to the ramp with the bars in it again, with the masses in it. Then we're going to loosen this, pull it back another 10 centimeters, and repeat. Now, notice as this ramp keeps coming back, as the ramp keeps coming back further and further and further, it gets shorter. In other words, the distance of the ramp in order to get to that height that we chose keeps getting shorter and shorter and shorter until eventually it goes vertical. If it's vertical, the ramp isn't really necessary, is it, to get to that highest point? So at that time, now we're just going to lift this straight up. We're going to take the force sensor and we're just going to lift it straight up at a constant velocity and get that last reading. So what we did is we got measurements of the ramp when it was long all the way until it was short like this. Force versus distance. You're going to get a curve, you're going to straighten that curve and derive an equation for work.